Hey everyone guys, in the last video we discussed about the bubble sort. We began with sorting, and in the last one we discussed about the application of bubble sort, the time complexity of what bubble sort is, how the logic of bubble sort works and all. So in this one we will be moving onwards with selection sort, the second type of sort there is. We will be talking about what selection sort is, how it's different from bubble sort, and what its time complexity is and all. So yeah, will be the way we talk about each topic is that we will be talking in depth as to what it is in the same category, how it's being compared to other ways it can be achieved, the sorting, which in this case is the thing, and some examples, dry run, and how the logic should be developed about the main topic that we are going to discuss. So yeah, let's start with selection sort. Alright, so we can take an array into consideration. Let's say it's 10, 7, 12, 15, 45 and 30 and 21. Alright, so I took 7 elements, n is equals to 7. Now we know that in bubble sort, the way the logic of sorting was working was that it ran two times, I and j times. J ran within the I, the outer loop was I times, it ran from 0 to n, so 7 times it ran, and in each time the jth element in j loop was being compared to its previous element, and if it was bigger than its previous element, then it was being swapped. And we saw that in bubble sort, the way the elements were being sorted were from the last. So 45 would be sorted first, then 30 would be sorted, then 15, then 7, and then that all, right? So we saw that from end of the array, in case of ascending order, the elements were being sorted in bubble sort. Now let's talk about how selection sort is, what selection sort is and how it is different from the application of bubble sort. So we can say that selection sort is somewhat similar to bubble sort because it will also sort the elements from the end, from end to beginning. It will run n times, but the complexity would not be big of n. That would not be the case. For bubble sort it was big of n square. For selection sort as well it is big of n square, but the way it works is somewhat different. So yeah, let's see as to why it's actually called selection sort. Alright, so let me change the color so it will be much easier to understand. Alright, so the way selection sort works is it will select the maximum element, which is 45 in this case, and it will place it to its last element. It will swap with the last element. Doesn't matter what the element in the last is, because we know that the maximum element that we chose would always be bigger than that last element, right? And that is the case. See, 45 is bigger than 21. 21 will be bigger than many more elements, 10, 7, 12, but it is not bigger than the maximum element. That's why we are swapping the majority element with the last element, and then every time the loop runs, the loop will run from 1 to n, 0 to n, means it will run 7 times, and each time the maximum element will be swapped with the last element. Now that is not exactly the case, because if we do that, let's say in the first time, in the I is equals to 0 means I is equals to 1, in the first round we know that 45 is the biggest element, so it will swap with 21. So it will look something like 10, 7, 12, 15. Now 45 is being swapped with 21, so it would be 21, 30 and 45. Now this iteration is correct. For the first time it will take the biggest element and it will take it to its correct position, which is in the end. Now like I said, every time it will pick the majority element and it will swap it with its correct position, which is in the end. So when I is equals to 2, now what is the biggest element in this all? It's again 45. Now we know that 45 is going to be swept with the correct in the last element, so it is actually there only. See, what I am saying it is that 45 is going to be swept with the last element. 45 is actually the last element, so why do we even need to consider 45 in the range? Because 45 is already sorted. So our new range should be 10 to 30, because we don't, if we consider 45, then we are going to be stuck in a loop, because every time it will choose 45, every time it will swap 45 with 45. So we don't even need to consider that once it is sorted. So our new range is 10 to 30, and we know that 30 is going to be the biggest element, the maximum element in this range. Now 30 is going to be swept with the last element. In this case we are lucky that 30 is the last element. So after swapping it, it should look something like 10, 7, 12, 15, 21, 30. If it was in some other index, then it would be swapped with here, and 45, which we already sorted it in the first round. In the third one, now we don't need to consider the last two elements, because if we start considering them, then it would be stuck in a timeless loop. So our new range should be 10 to 21. So 10 to 21, the majority element is 21. Again it is in the correct position because it is at the last element in this range. So it would look something like 10, 7, 12, 15, 21, 30 and 45. Yep, that is correct. Now our new range of finding the maximum element should start from 10 to 15. Again we know that 15 is the maximum element. It is sorted in the correct position. So it would look something like 10, 7, 12. Actually I somehow took the most convenient array for sorting. It's partially already sorted. That should not be the case, means we are not that lucky. Alright, so 10 to 12, again it's sorted. Then 10 to 7. Alright, so we can skip the fifth one. So in sixth round, 0 to 6, we are running from 0 to 6, so it's sorting the last element. So between 10 and 7, 10 is the biggest one, so it would be swapped with the last element. So 7, 10, 12, 15, 21, 30 and 45. So by the end we reach our last index in the iteration, means when we are in the last round of swapping elements, the last element will always be sorted in its correct place, because in the last iteration we know that only one place remains to be sorted with one other, and if those two go to their correct places, then we don't need to go with the last element again, because it's going to be sorted. So why even run that last time? So basically it's going to be run with n minus 1 times, so 6 times it runs. See, because 7th one will always be sorted if all the 6 ones are sorted in 7 elements. So n minus 1 times we are going to run the loop. Now like I said, looking with this, we can say that the complexity is big of n times, but no, that is not the case, because we know that in every time, in every iteration, we are also finding the maximum element, and to find the maximum element we are actually running from a particular range. Our start range always remains to 0. In our end range, the range we are always decreasing it with I times, n minus I times, not the n times, n minus, so only I times. So yeah, actually sorry, my bad, it's actually n minus I times. So because in the first time we are considering the entire array when I is 0, in the second one we are considering from the second last when I is 1, so n minus I times is the way we find our maximum. So basically we need two functions. The first one would be the main sorting function. This is the main function, and the second one should be the helper function, which helps us to find the maximum element in that given range. So let's discuss about those two functions. So we can it's basically very simple now that you know the application of how and why, what the process of selection sorting is. It's basically very simple. We swap the two elements, thus swapping the maximum element with the last element in the given range. Alright, so our max function should take in the array, it should take in the start position of the range and the end position of the range. alright, because we are taking the start and end positions because it's changing every time. The start will remain the same, we don't need to take that, but the end would, you know, that will change, that will reduce by 1 every time, so we need to take that. Alright, so we can run the loop one time. For I is equals to 0, I runs from sorry, not 0, I start, I less than end, I plus plus. Alright, we can take a helper variable which is the max element. We can declare it the start position because we know it will be iterated every time, and if at any time this max element is less than the ith element, then we simply take the ith index, then we reinitialize the maximum with the ith position. By the end of this for loop, we will be getting our max index. We can return the max index from that range, which is start to end. So this is our helper function. It's very simple. Now this max function will be used every time in the main function, which is the sorting. So we can take in the sort function here. It will simply take in the array, we don't need anything else. We can thus, alright, there is one small confusion, I'll clear that out. I said that the main sorting function will take place from 0 to n. We are not cutting down any ranges from there. In the main sort function, we are not going to cut the ranges. We are only cutting the ranges in the max function. The max function will always have variable lengths of ranges from which we are going to find the max. The main sorting function will run from 0 to n. It has to sort all the elements. It won't skip anything. The max function, that is where we are skipping the last element one by one every time it finds the majority element. Alright, so sort function will run from 0 to n, and each time it will find the max index. The max index will be found using the max, and our ranges would be 0 and we are giving the array first, right? So we are giving the array 0 and n minus I. Yep, that's the case. Alright, so every time we are taking the and n, basically we should declare over here is air dot length minus 1. Alright, so n minus I. Every time we are figuring out the maximum element by from that range. So once we get our maximum element, we will swap it with the last index, so which is this n minus I times. Alright, so the swap the max element with the last index, which is n minus I. Alright, so I hope you remember that in the last one we also sorted the similar way. So we can create a temp variable which is max element. This max element will now be swapped with the last element n minus I. The last element will now hold the temp variable. Yeah, that's the case. That's the temp, and this temp has the max value because here, see, that's a simple loop. It's a very basic swap function, and in the end, after the main loop, this is a for loop, by the way. I hope you can understand all the pseudo code that I am writing, because this is not the real code, it's basically helping you to understand all the logic. So once this loop ends, we can simply return the array. Alright, so these two are basically simple functions that will help us understand the application of how selection sort is different from bubble sort. So like I said that even though that we are running the main loop one time, which is 0 to n, it's still not big O of n. It's basically going to be big O of n square, because every time we are also finding the max element which is running from 0 to n, means 0 to its selected range. But in the worst case, it is in the first, where if you consider the first case over here, it's going to run from 1 to n, because we are considering the entire array for the first element. The very most maximum element, which is going to be 45 in this case, it has to run from 0 to n to find that maximum element to place it to the last element. So in that case, it is running n square times. So our complexity is big O of n square, which is similar to the bubble sort. And so yeah, the main application that I wanted to discuss is it's somewhat similar to how bubble sorting works, because it is, in this case also, it's going to sort from the last order. So 45 will be sorted first, then 30, then 21, then 15, then 12, 7, 10. So let's discuss about the best and worst cases. So this is very common, when we talk about sorting. The best case is always going to be that the array is already sorted in ascending or descending order in the way we want to find. So it's given as the way we want it to be. And in the worst case, it's going to be the exact opposite. So if we are given the question to sort it in the ascending order and we are given the array in descending, then we need to swap all the elements all the times in each iteration. So that's the worst case for ascending order. For descending order, if we are given the array in descending order and we are asked to sort it in ascending order, then we need to consider it as the worst case, because for descending, ascending is the worst case, for ascending, descending is the worst case. So yeah, similar for bubble sort, because sorting is same, the application is same, only the way we are taking in the elements, the way we are looping all the elements one by one, that's what changes. So yeah, I hope you understood the differences and application and the logic behind how selection sort is working over here. Next video we'll be discussing about few more sorts. We'll be talking about some questions related to it and all. So yeah, I hope you enjoyed this one. Thank you.